Hello there, audience. We are back with another episode of The Cloud Show. Today, we're going to talk about a different topic that we haven't actually approached here on this show before. It's something called resilient programming. And the question is, what the heck is resilient programming? Joining us today is the star of the show, is a person who has built an open source .NET project or .NET framework project called Cleipnir, Cleipnir.net, really, which is then designed to make it easier to implement business flows where you have multiple external services being used at the same time together in conjunction. So let's talk to the star of the show today. It is Magnus Sylvest. Hi, Thomas.
Hi, Magnus.
Welcome to the show. Yeah, we were just talking about how we are neighbors of sorts.
Yeah. I guess in America we will be very neighbors.
Next state,
in Europe,
this next country, though. You're in Denmark and I'm in Sweden. So, tell us a little bit about yourself. What do you do, and how come you're doing open source and stuff?
Yeah, sure. Yeah, good question. So I'm a backend software developer. I have 12 years of experience now since I finished university, and I work for different banks and different big companies. When I was at Danske Bank, which is the biggest bank in Denmark, we did some event sourcing framework and everything. And as part of that, I started thinking about distributed systems, and I wanted to go back and study. So actually, I approached the university in Stavanger in Norway, where they have a team, I guess, where they focus on distributed systems.
Right.
And that was kind of like the way that I got into this space, really, because part of what I was trying to do was so you have Raft and Paxos, with the famous algorithms, and kind of you have them in etcd. It's based on Raft, and so you have these kind of very fundamental distributed system algorithms.
Right.
And I was trying to basically to simplify the way that you would implement these things, because one of the things that is a bit difficult with them is that you get messages. You have to wait for X number of messages before you continue, and if you have a crash doing that, you could say run, then that poses all kind of problems. So
right.
So that was kind of
So that's what you were doing with that. Let's pull it back just a little bit, just to put it in a business context, to figure out first for the audience what kind of a problem is that we are trying to solve here.
Yeah.
We have something called resilient programming, and we need to implement our business flows using multiple services. What's this about?
Yeah, it's a good question. Yeah, so all this very theoretical stuff is actually also, I realized after doing my studies, that it actually makes sense in a different space, which is microservice architectures and enterprise architectures in general, because when you have a business flow that communicates with other external systems, which is basically almost any flow these days, right? Even a database, you could say, is an external system.
Right.
You have to take care of the situations. What happens if the system crashes while executing these things?
Yep.
And today, actually, we also have another avenue where we also see this problem, and that is when we have releases, right, deployments of our software with new code, that we're actually inducing crashes, I guess you could say, ourselves, right, because we are flipping rolling releases, right, so we're restarting our services, and we can't just wait arbitrarily long. So
that's a fair point.
Yeah, so kind of what it's trying to solve is how do we actually go about ensuring that when a system restarts after it's halfway through whatever flow it's doing, how can it pick up from that point and continue
where it was before?
Where it was before. And that's actually not that easy, there's different examples, but I guess if you just like imagine an order flow where the first thing it does is kind of like it generates a random transaction ID, right? Let's say that it should talk to Stripe and generates the random transaction ID, and then it reserves the funds and it ships the products, and then it crashes before it actually is able to capture the funds. If you just restart the flow from the top again, then the flow will generate a new GUID, right? A new transaction, and then you actually have that it's diverging into a different state.
That's right. That's right.
Yeah.
So what you want to be able to do is replay and kind of pick up where you left off or where you were interrupted so rudely, right? It could literally be an update to a system that is part of this flow, where you are currently rolling out an update to that system, and now everything else that wants to use that system needs to wait for a bit. It's not going to work until this comes back on again. Yeah. And easy as it sounds, theoretically, to break down a system into lots of different microservices, you get this tango problem. Everybody needs to dance, right?
Yeah, yeah, exactly.
That's very cool.
So it's simple, to break up into microservices, but you introduce a lot of different issues.
I can see that. Okay, so that's brilliant. So you have been then coding on on an open source project of your own called Cleipnir, which then is a framework that can do these things. It can model business flows. So
what it tries to do, there's different approaches also in the cloud space. I think AWS has like is it a YAML definition? You can do like workflows using But a different approach is that you try to allow the developer to use code, like ordinary code, and then you do some different calls or wrap the code in a certain way that allows this replay to be able to happen after a crash. But the code is very much normal code, so it's not like So it's not like a YAML file or something completely different. It's what the developer is already used to.
Right. And that's a good point, because if you have this workflow language, which is a completely separate thing, then you have to know two things, and you have to maintain two things.
Yeah.
But if you can express your workflow in code, then you are on home field, because you already do code every day.
Yeah.
Right?
Yeah, exactly. Okay. Yeah, and you can do integration tests, unit tests, all these things. So you get all the nice things that you already have. When you code anyway. So that's really what it's about. Then I'm also trying a bit to not just to copy what I guess some of the other alternatives that are like Azure Doable Functions and Dapper and also Temporal. I'm trying to make it simpler developer experience, and also there's as far as I know, at least, these frameworks do not handle like receiving lots of different messages. So a lot of the times in microservice architectures, you have a situation where you want to wait for X number of messages, or you have a flow and you have messages coming in from a message bus. And that's also something that is similar to Link, really. You can write kind of like, I want to wait for these messages, and then I want to do something. And that's also, you're also able to write that in a way that if you crash and then restart, you can still continue from the point where you got to. That's kind of like,
interesting. Yeah. So how does this thing then? What happens if you are halfway through? Then you have some state and some data that you need to remember somehow, and then pick up and continue. How does it handle this?
Yeah, so all of these frameworks, they have like a persistence layer, and Cleipnir you can use the different SQL servers. So you have a Postgres and SQL server, and also MySQL. It can be other things as well. It doesn't have to be a relational database, but I guess they're the most common ones. So basically, as you go along doing your flow, the framework writes the different state changes or what happens to the database, and then if it crashes and it starts up again, it just loads all of these different actions or side effects that happens previously.
He just goes, okay, I'm back. Okay, where was I?
Yeah, exactly. Yeah. What happened?
What happened? Okay, I'm back. All right, that's cool. And so essentially, what you're saying is that to run this thing, and let's talk a little bit about that. You need to have a database somewhere in the background, and the framework is talking to the database. The developer is not using. They just have a database, but the developer is expressing things which are then persisted. The progress steps are then persisted automatically on the back end. All right, exactly, cool. Very cool. Yeah, so how does a developer get into using this? How do they start if they wanted to use Cleipnir, and like what? How does Cleipnir run? Where and how does it run?
Yeah, good question. So you can just visit the address Cleipnir.net. That will redirect to the GitHub page, which has a lot of documentations about how to get started. But the idea basically is that it should be as simple as possible. So you just download a NuGet package, and then you can do a bit of setup in the program CS, and then you're up and running. Then you define these different flows just by inheriting from a base class, and then you're ready to go. That will kind of like give you the different abstractions or tools that the developer needs to actually start using the framework.
That's really cool. So you wanted it to be really simple then. So for those of us who are developers here, they understood what you just said, and I get what you're talking about. I love how easy it sounds to use. Really, essentially just point to the reference the package, get it downloaded, and inherit the base class and doing some configuration, and you're off to the races.
Yeah, exactly. Yeah, that's all it is. So the idea was that it was kind of like meant to work very seamlessly in like microservice architectures. So you can just have your microservice and you can add this framework to your microservice, and then it will just scale behind the scenes so it doesn't matter if you replicate from 3 to 5 to 7 or. I mean, the framework and behind will just also scale in the same way. So
fascinating. And so you just then you just had this idea based on what you were experiencing then when you were working with customers, I guess.
Yeah. So it came from I guess my time at the university, where I was able to see, okay, actually we can make these complicated algorithms simpler. But then when I finished that and got back into industry, I also worked for another bank at that point. I could see that there was a lot of, like you talk about sagas and stuff. You have these distributed or these patterns in distributed systems, and the developer experience when actually writing these sagas or workflows was not very pleasant. It was very far from what you would write in normal code. And that kind of like got me thinking that I could take the ideas from my studies and then actually apply them into this space instead. So
how are you using it yourself today? Do you have any? Well, you don't have to tell me exactly which projects, but do you have any interesting projects that are using this now?
So I'm still. I mean, actually, that could be another talking about how it's hard to get open source. You have a bit of a chicken and egg problem.
Definitely.
I mean, I've presented it quite a few times, and people really like it. So that's good. I think it's a bit difficult, I guess, in your workplace to kind of like take these things, and they're interested, but I think it will still be maybe half a year before they will get ready to use it.
It's a scaling thing then. So just like if you don't have any projects running it, then you will never have any projects running it. I shouldn't say never. That sounds harsh. Basically, I'm not saying you heard it here first, because I did look up a video where you presented this already with the Microsoft guy and then I also I did take a look at the code a little bit, and I would definitely agree that this is cool, and it seems I haven't really gotten down to code anything with it, but I could completely follow along, and it wasn't difficult. It was intuitive. So I hope that you will have, good fortunes with this.
No, thank you, Magnus. Thank you. I think the point, at least for people seeing it, if they're interested, I mean, do reach out. Or I guess otherwise, it's always nice if you have kind of like just a simple. You don't have to do a big bang and everything runs on this, but you could just have like a scenario where you say, okay, let's have a look. How does it work? I mean, that's a lot of tests, and I've worked on it for I guess 3 years now. So.
Wow.
It should be in a pretty good state, but yeah.
There you go. So if you want to help out with this very interesting topic or project, open source project, you should contact Thomas and offer to help.
Definitely, yeah.
Sounds brilliant.
Any help and any feedback would be really appreciated. Yeah, definitely.
Fantastic. Well, I have to tell you that I love this kind of geekery, just to get down to it and talk. We didn't show code here today. Of course, it's not really the purpose of this show, but we did get to talk about how it works and how it ticks and why it exists and all these interesting things. And I think that's plenty fascinating, and I love this kind of geekery. So
that's good.
I really want to thank you for being on the show today. It was a pleasure to have you, and I wish you the best of luck with Cleipnir and your open source project. Go for it.
Oh, thank you, Magnus. Yeah, thank you for having me. Really
absolutely, it was my pleasure. Have a great day, and audience. See you next time on the Cloud Show.